The 831 divider is designed to divide a three-phase power supply into three single-phase supplies. Each single-phase supply derived from the 831 divider will have the same voltage as the original three-phase supply, but the available current on each phase will be approximately one-third of the total three-phase current. This characteristic of the 831 divider makes it suitable for situations where you want to distribute a three-phase power source to multiple single-phase loads. The application involves using a 480 volts three-phase circuit to supply power to 480 volts single-phase fixtures, which is a practical approach to mitigate voltage drop and optimize circuit sizing. The 831 divider can indeed be used in this scenario. It effectively splits the incoming three-phase power into three distinct single-phase outputs, each providing 480 volts. Then, you can connect the single-phase fixtures to these individual single-phase supplies originating from the divider. Connecting single-phase loads to a three-phase system using a device like the 831 divider involves several important considerations to ensure proper operation and safety. Firstly, you must ensure balanced loading across the three phases to prevent excessive current on any one phase, which can lead to overheating and equipment failure. Ideally, the total power consumption of the single-phase loads connected to each phase should be roughly equal. Secondly, proper wiring and overcurrent protection are crucial. The size of the conductors used to connect the fixtures to the divider and the size of the circuit breakers or fuses protecting those circuits must be appropriate for the current draw of the fixtures. Consult the National Electrical Code, or NEC, tables for guidance on selecting the correct wire size and overcurrent protection based on the ampacity of the conductors and the load requirements. Thirdly, grounding is essential for safety. Ensure that all fixtures and the 831 divider are properly grounded according to local electrical codes to provide a path for fault current and minimize the risk of electric shock. The 831 divider is particularly beneficial in large parking lot lighting installations where you have numerous pole lights that require significant power. By utilizing the three-phase system and the divider, you can distribute the load more evenly, reducing the overall current in each phase and minimizing voltage drop over long distances. This results in brighter, more consistent lighting across the entire parking lot. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause lights to dim, motors to run inefficiently, and other equipment to malfunction. By using a three-phase system and distributing the load, you can significantly reduce voltage drop compared to using a single-phase system for the entire installation. The 831 divider is a cost-effective solution. While it adds some initial cost to the installation, it can save money in the long run by reducing the size of the conductors needed, minimizing voltage drop, and improving the overall efficiency of the lighting system. The installation requires careful planning. Before installing the 831 divider and connecting the fixtures, carefully plan the layout of the lighting system, calculate the load requirements of each fixture, and determine the appropriate wire sizes and overcurrent protection. It is also important to consult with a qualified electrician to ensure that the installation complies with all applicable electrical codes and safety regulations. When working with electrical systems, safety should always be the top priority. Always disconnect the power before working on any electrical equipment, and use appropriate personal protective equipment, such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to hire a qualified electrician to do the work. The benefits of using the 831 divider are many, including reduced voltage drop. By distributing the load across three phases, the current in each phase is reduced, which minimizes voltage drop. This is particularly important in long wire runs, such as those found in large parking lots. Improved circuit sizing. Using a three-phase system allows for smaller conductor sizes compared to a single-phase system carrying the same load. This can save money on materials and labor. Balanced loading. By distributing the load evenly across the three phases, you can prevent overloading any one phase, which can lead to overheating and equipment failure. Increased efficiency. Reducing voltage drop and balancing the load can improve the overall efficiency of the lighting system, saving energy and money. A note on wire size selection is warranted. Selecting the correct wire size for the installation is crucial for safety and performance. The wire size must be large enough to carry the current draw of the fixtures without overheating or causing excessive voltage drop. The National Electrical Code, Section 310.15, provides tables and guidelines for determining the appropriate wire size based on the ampacity of the conductor, the ambient temperature, and other factors. In addition to wire size, it is also important to select the correct type of wire for the application. For outdoor installations, use a wire that is rated for direct burial or that is installed in a conduit to protect it from the elements. Proper grounding techniques need to be followed as well. Grounding is essential for safety and helps to prevent electrical shock. All fixtures and the 831 divider must be properly grounded according to local electrical codes. This typically involves connecting the equipment to a grounding electrode, such as a ground rod or a metal water pipe, using a grounding conductor. The importance of overcurrent protection cannot be overstated. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect the wiring and equipment from damage caused by excessive current. The overcurrent protection device should be sized appropriately for the ampacity of the circuit and the load requirements of the fixtures. The placement and accessibility of the 831 divider needs to be considered. Choose a location for the 831 divider that is easily accessible for maintenance and inspection. The location should also be protected from the elements and unauthorized access. The NEC Section 110.26 outlines requirements for working spaces about electrical equipment. Understanding three-phase power is essential to understanding the 831 divider's function. Three-phase power is a type of alternating current (AC) power that uses three conductors to deliver electricity. These three phases are typically labeled A, B, and C, and they are offset from each other by 120 electrical degrees. This offset helps to provide a more constant and efficient power delivery compared to single-phase power. In a three-phase system, the voltage between any two phases, such as A and B, B and C, or C and A, is called the line-to-line voltage. In a 480 volts three-phase system, the line-to-line voltage is 480 volts. The voltage between any one phase and the neutral conductor, if present, is called the line-to-neutral voltage. In a 480 volts three-phase Y system, the line-to-neutral voltage is approximately 277 volts. The power delivered by a three-phase system is calculated using the following formula: power equals the square root of 3 times the line-to-line voltage times the current times a power factor. The power factor is a measure of how efficiently the electrical power is being used. A power factor of 1 indicates perfect efficiency, while a power factor less than 1 indicates that some of the power is being wasted. Understanding single-phase power is useful in the context of the 831 divider. Single-phase power is a type of AC power that uses only 2 conductors to deliver electricity. These 2 conductors are typically labeled the hot wire and the neutral wire. The voltage between the hot wire and the neutral wire is called the voltage. In a standard single-phase system in the United States, the voltage is typically 120 volts or 240 volts. The power delivered by a single-phase system is calculated using the following formula: power equals the voltage times the current times the power factor. The 831 divider takes a 3-phase input and provides 3 single-phase outputs. Each of these single-phase outputs has a voltage equal to the line-to-neutral voltage of the 3-phase input. So, if the 3-phase input is 480 volts, then each single-phase output will be approximately 277 volts. However, in this case you will be using 480 volt rated single-phase equipment. This implies that the transformer is configured differently and the single-phase output will have a voltage equal to the line-to-line voltage, which is 480 volts. The maximum current that each single-phase output can provide is limited by the current capacity of the 831 divider and the current capacity of the wiring connected to it. It is important to ensure that the total current draw of all the single-phase loads connected to the 831 divider does not exceed the current capacity of the divider or the wiring. The advantages of using a three-phase system with an 831 divider for single-phase loads can be significant, especially in large installations like parking lots. Three-phase systems can deliver more power than single-phase systems using the same size conductors. This is because the power is distributed across three phases instead of just one. This can result in lower installation costs, as smaller conductors can be used. Three-phase systems are more efficient than single-phase systems. This is because the power is delivered more smoothly and consistently, which reduces losses due to voltage drop and other factors. This can result in lower energy costs. Three-phase systems are more reliable than single-phase systems. This is because if one phase fails, the other two phases can continue to provide power, albeit at a reduced level. This can help to prevent disruptions in service. The 831 divider is a relatively simple and cost-effective way to convert three-phase power to single-phase power. It is a passive device, meaning that it does not require any external power to operate. It is also relatively small and lightweight, making it easy to install. The limitations of using a three-phase system with an 831 divider for single-phase loads should be known. The 831 divider is not a perfect solution. It does have some limitations that should be considered before using it. The 831 divider can only provide a limited amount of current on each single-phase output. It is important to ensure that the total current draw of all the single-phase loads connected to the 831 divider does not exceed the current capacity of the divider or the wiring. The 831 divider can introduce some voltage imbalance into the three-phase system. This is because the single-phase loads connected to the 831 divider may not be perfectly balanced across the three phases. Voltage imbalance can cause problems with some types of equipment, such as motors. The 831 divider can generate some harmonics into the three-phase system. Harmonics are unwanted frequencies that can cause problems with some types of equipment. The 831 divider should be installed and maintained by a qualified electrician. The installation of an 831 divider requires careful planning and execution. It is important to follow all applicable electrical codes and safety regulations. The 831 divider should be inspected regularly for any signs of damage or wear. Any damaged or worn part should be replaced immediately. When designing a lighting system for a large parking lot, several factors must be considered to ensure adequate illumination, energy efficiency, and safety. The choice of light fixtures is paramount. Select fixtures that provide the appropriate light distribution pattern for the area being illuminated. For parking lots, fixtures with a wide distribution pattern are often preferred to maximize coverage and minimize the number of poles required. LED fixtures are a popular choice due to their high energy efficiency, long lifespan, and low maintenance requirements. Consider the color temperature of the light. A color temperature of around 4000 to 5000 Kelvin provides a bright, white light that is ideal for parking lots. Lower color temperatures can create a warmer, more inviting atmosphere, but may not provide adequate illumination for security purposes. The light level, measured in foot candles or lux, is a critical factor in parking lot lighting design. The Illuminating Engineering Society, or WISE, recommends light levels of at least 1 foot candle for general parking areas and 3 foot candles for pedestrian walkways and entrances. It is important to consider the uniformity of the lighting. Uniform lighting ensures that there are no dark spots or areas of excessive brightness, which can improve visibility and safety. Aim for a uniformity ratio of no more than 4:1, meaning that the brightest spot is no more than 4 times brighter than the dimmest spot. The placement of light poles should be carefully planned to maximize coverage and minimize glare. Consider the height of the poles, the spacing between poles, and the angle of the fixtures. It is also important to avoid placing poles in locations where they could be easily damaged by vehicles. Use a lighting control system to reduce energy consumption. A lighting control system can automatically dim or turn off lights when they are not needed. This can save significant energy and money over time. Consider using occupancy sensors to turn on lights only when someone is present. This can be particularly effective in areas that are not used frequently. Use a timer to turn off lights at a certain time of night. This can be useful for areas that are not used after hours. A photocell can automatically turn on lights when it gets dark and turn them off when it gets light. This can help to ensure that the parking lot is always adequately illuminated. Consider the environmental impact of the lighting system. Choose fixtures that are energy efficient and have a long lifespan. Use a lighting control system to reduce energy consumption. Avoid light pollution by using fixtures that direct light downward and minimize upward spill light. Consider the maintenance requirements of the lighting system. Choose fixtures that are easy to maintain and have a long lifespan. Use a lighting control system to monitor the performance of the lighting system and identify any problems early on.